Hi students, this is the second class of industrial hydraulics. In this section, I am going to discuss about properties of hydraulic fluid. This is a very important topic, usually asking as essay question. Explain the different properties of hydraulic fluids. See, there are several properties of hydraulic fluid. First of all, viscosity, lubrication capability, demulsibility, chemical stability, neutralization number, flash point and fire point, low flammability, foam resistance, low volatility, good heat dissipation, cleanness. Almost 12 properties of hydraulic fluids. So first of all, viscosity. Viscosity is a measure of resistance to flow of fluids. Hydraulic oil should have an optimum viscosity. See, if the viscosity of hydraulic oil is low, the hydraulic oil will flow very easily. If the viscosity is high, it is very difficult to flow of hydraulic oil. See, viscosity of a hydraulic fluid should be high enough to seal the working gap between the parts and prevent leakage, but should be low enough to cause easy flow through the system. See once more, what is the definition of a viscosity of a hydraulic oil is, it is a resistance to flow of fluids. First point. And hydraulic fluid should have an optimum viscosity. If the viscosity is low, the hydraulic oil will flow easily through the hydraulic system, different components of hydraulic system. If the viscosity is high, it is very difficult to flow of hydraulic fluids. See, hydraulic viscosity of a hydraulic fluid should be high. It should be high to seal the working gap between the part and prevent leakage, but it should be low enough to cause easy flow through the system. So these points should be right for viscosity property. Second property of hydraulic fluid is the lubrication capability. See, in a hydraulic system, when we are using a hydraulic oil itself acts as a lubricant. There is no separate lubricant is required. See, what's the purpose of lubrication in hydraulic oil is which prevent friction and wear between the closely fitting working parts. Friction and wear which prevent friction and wear between the closely fitting working part. That's important point. So due to wear, there will be small amount of material will be removing from the surface due to frictional force between the two metal to metal contact of surface. So that should be avoided by adding lubrication. So hydraulic oil itself acts as a lubricant to prevent friction and wear. See, the hydraulic oil film should be so formed, should be strong enough that it should not be wiped out by moving parts. So there is a thin film that will be formed between the moving parts. It should have enough strength. It should not be wiped out due to the moving part. Third property is the demulsibility. See, demulsibility means prevent emulsification. See, hydraulic oil, when emulsifies with water, it promote the destruction of lubricating and sealant properties. If the hydraulic oil will be emulsifies with water, it will it will promote the destruction of lubricating and sealant properties of hydraulic oil. So ability of a fluid to separate rapidly from moisture and sufficiently resist emulsification is called demulsibility. So demulsibility means successfully resist emulsification. That is the meaning of demulsibility. See, hydraulic oils are basically water resistant in nature in order to prevent emulsification. So fourth property of hydraulic oil is chemical stability. Chemical stability can be defined as the liquid ability to resist oxidation and deterioration for a long time. So chemical stability means hydraulic oil should have the ability to resist oxidation and deterioration for a long time. For a good hydraulic fluid should have a good chemical stability. See, Hydraulic oil, like mineral oil and petroleum oils, contain carbon and hydrogen which easily react with oxygen and form oxides. And these oxides are soluble in oil and acidic in nature and which will corrode the metal parts. So what is the importance of chemical stability means which chemical if the hydraulic oil is not chemically stable it will increase oxidization and oxidization increase corrosion of the metal part. So hydraulic oil should chemically stable to prevent oxidization and deterioration for a long time. Fifth property is the neutralization number. This is a very important property, neutralization number. See, neutralization number is the measure of relative acidity or alkalinity of a hydraulic fluid and specified by pH value. So, neutralization number that is always specified by pH value. So, it is a measure of alkalinity or acidity of a hydraulic oil. So, all hydraulic oil should have a small neutralization number. If the neutralization number is high, it have high acidity or high alkalinity fluids. High acidity always causes oxidation, increasing oxidation rate, and it will increase the corrosion rate in metal part. So neutralization number should be always kept as low for a hydraulic oil. It will reduce the oxidation and reduce the corrosion of metal part. See, sixth and seventh, flash point and fire point. See, how will you define the flash point? Flash point is the lowest temperature at which fuel releases flammable vapor in air and produce flash in presence of ignition source. That's the definition of flash point. See, flash point is the lowest temperature at which fuel releases flammable vapor in air and produce flash in the presence of ignition source. For example, we are taking a certain amount of hydraulic oil in a jar and burning it by firing. Start to fire. A thermometer is dipped here. So when the hydraulic oil is heating, it will get vaporized. At the same time, there is an ignition source. So at which temperature or lowest temperature at which the fuel releases flammable vapor in air and produce flash in the presence of ignition source is known as flash point. Flash point should be as high as possible for a good hydraulic oil to prevent fire hazard. For prevent fire hazard, flash point of the hydraulic oil should be kept as high. Then what do you mean by fire point? See, fire point is also the lowest temperature. So fire point is the lowest temperature at which vapor of that fuel will burn at least 5 seconds when exposed to open flame. See, the fire will be there at least 5 seconds if we are removing the ignition source also. In flash point, in the case of flash point, only the presence of ignition source, the flash will be there. In fire point, when we are removing the ignition source, there will be flash for at least 5 seconds. So lowest temperature at which vapor of that fuel will burn at least 5 seconds when exposed to an open flame. See, fire point should be as high as possible for a good hydraulic oil to prevent fire hazard. Okay, see, in the case of fire point, the burning of fire will be remains there after removing the ignition source also at least 5 seconds. So flash point and fire point are very important properties of hydraulic oil and it should be keep as high value for a hydraulic oil for prevent fire hazards. Eighth one is the low flammability. Hydraulic oil should have low flammability means fire resistance. So low flammable fire resistant hydraulic oil are commonly using not to reduce fire hazards. Ninth property is the foam resistance. See, foam resistance is defined as a property of hydraulic oil to resist dissolving oxygen. It's a property of hydraulic oil to resist dissolving oxygen. If the air is dissolved in hydraulic oil, air bubbles will form. These air bubbles rise slowly to the surface of the hydraulic oil. And if the air bubbles are drawn by the pump, this causes damage due to cavitation. So cavitation will be occur. So dissolved air also reduce the bulk modulus of the hydraulic coil. That's very important point. When the air is dissolved in the hydraulic coil, the bulk modulus will be reduced. So form resistance means the property of hydraulic oil to resist dissolving oxygen. If the air is trapped inside the hydraulic oil, these air bubbles slowly move to the top of the hydraulic oil. If the pump is down by the air bubbles, it will cause cavitation to the pump. 10th property of hydraulic oil is the low volatility. See, hydraulic oil should have low vapor pressure, high boiling points. See, all hydraulic oil we are choosing should have high vapor pressure or low vapor pressure, not high, low vapor pressure or high boiling point. Should not boil as fast as possible. Should have high boiling point. 11th property of hydraulic oil is the good heat dissipation capacity. Hydraulic oil should have a good heat dissipation capability. See, if the hydraulic oil have less heat dissipation capability, the temperature of the hydraulic oil should be shoot up easily. Too high temperature cause system to malfunction. See, if the fluid overheat, hydraulic oil overheat may cause vapor also. So, while we are choosing a hydraulic oil, it should have a good heat dissipation capacity. Last property of hydraulic oil is the cleanness. See, cleanness, this property is very important in the case of hydraulic system that is used in aerospace applications. There is no external impurities or foreign particles should be contained in the hydraulic oil. It should be removed by certain type of filter before the hydraulic oil reaching into the hydraulic system. In aerospace applications are commonly highly sensitive to contamination. So highly cleaned hydraulic oils are commonly used in aerospace application and all. So these are the properties of hydraulic oil. So we have 12 properties of hydraulic oil you have to study. That is viscosity, first property, then lubrication capability, demulsibility, chemical stability, neutralization number, flash point, fire point, low flammability, foam resistance, low volatility, good heat dissipation, cleanness. The next one is viscosity index. What is the importance of viscosity index? See, viscosity index is a relationship between change in viscosity with the temperature. That's the first point. Viscosity index of a hydraulic oil is the relationship between change in viscosity with respect to temperature. See, viscosity index is the relation between the change in viscosity with respect to temperature. And viscosity index is used to study the behavior of viscosity with the temperature of the hydraulic oil. See, when the temperature will changing, viscosity of the hydraulic oil will be also changing. So that relationship is known as viscosity index. Actually, viscosity index tell you how well a fluid can protect its viscosity during change in temperature. Viscosity index will tell you how a fluid can protect its viscosity during change in temperature. See, when the temperature will be increasing, viscosity will be decreasing. When the temperature will be increasing, viscosity will be decreasing. How? When the temperature will increasing, the energy of the molecules will bring out a change in rate of movement of molecules between the sheet of liquid. See, greater the viscosity index, lesser will be the change in viscosity with the change in viscosity with respect to temperature. So viscosity index should be as high as possible for a hydraulic oil because it should have less change in viscosity when temperature change. So that's the importance of viscosity index. Once more, see, viscosity index is an arbitrary measure of change in viscosity with respect to change in temperature. See, when the temperature changing, viscosity also will be changing. So viscosity index tells you how well a fluid hydraulic oil can protect its viscosity when temperature changes. See, hydraulic oil should have a greater viscosity value because there should be less change in viscosity with respect to change in temperature. So how will you measure the viscosity index? See, viscosity index are actually arbitrary measure. It is a relative measurement of viscosity of a particular oil with respect to some reference oil. See, viscosity index is usually measured by comparing zero viscosity index fluid, that is naphthenic, and 100 viscosity index fluid, that is paraffinic. So suppose we want to measure the viscosity index of a particular hydraulic oil, we are comparing the viscosity of that hydraulic oil with a zero viscosity index naphthenic oil and 100 viscosity index paraffinic oil, hydraulic oil. That's the importance. So viscosity index is a number given to hydraulic oil corresponding to its change in viscosity with respect to change in temperature. Greater the viscosity index, lesser will be the change in viscosity with respect to change in temperature. Viscosity index should be as high as possible for a hydraulic oil. So what's the importance of viscosity index? What's the importance of viscosity index? See, while we are using hydraulic oil as a lubricant in automotive application, see, when the engine is starting, before the engine will be starting at a cold condition, that is at atmospheric temperature. Now, while the engine is running, the temperature will be 250 to 300 degrees Celsius when running. So there will be a large change in temperature. So there is a chance that if we are using a low viscosity index hydraulic oil in automobile applications, the viscosity value of the hydraulic oil will be tremendously changing. So in automobile application, high viscosity hydraulic oils are using as lubricant greater than 130. Viscosity value greater than 130 are commonly uh, using in automobile applications. So we have a chart, viscosity index classification. If the viscosity index is under 35, low, 35 to 80 medium, 80 to 110 high, above 110 very high. Then what's the equation for measuring viscosity index, calculating viscosity index? Viscosity index can be calculated by following formula. Viscosity index is equal to 100 into L minus U divided by L minus H. U is oil kinematic viscosity at 40 degrees Celsius. L and H are values based on the oil kinematic viscosity at 100 degrees Celsius. So this is a very important equation. We have to solve some problems based on this equation. See, this viscosity index topic is very important. Usually in university examination there is a question regarding viscosity and viscosity index. What is the viscosity index? What's the importance of viscosity index of hydraulic oil, like etc. That's an important topic, viscosity index, and this equation and problem. Okay, so we have next I'm going to discuss about some general properties of hydraulic oil or a fluid. Density defined as mass per unit volume. So density indicated by rho, mass by volume, kilogram per meter cube is the unit. Density increases with pressure and decreases with temperature. Specific weight defined as weight per unit volume. You can see that weight by volume. So density is equal to specific weight by gravity. So specific weight is equal to density into gravity. Unit kilogram per meter cube. Specific volume, volume occupied by a unit mass of fluid, unit meter cube by kilogram. It is reciprocal of density 1 by rho. Specific gravity of a given fluid is defined as the specific weight of the fluid divided by specific weight of water. Specific gravity of oil is equal to specific weight of oil divided by specific weight of water. See, specific weight gravity is a dimensionless ratio. Then we have bulk models. That's important. Bulk modulus is a measure of the compressibility of a liquid and is required when it is desired to calculate the oil volume change for high pressure and large system volume. So you have to just understand what is bulk modulus is a measure of compressibility of a liquid. That's all. Bulk modulus is equal to increase of pressure divided by volumetric strain. That's the equation which is used to find out the bulk modulus. So these are general properties of a fluid. The general properties of a fluid. So we have density, specific weight, specific volume, specific gravity, then bulk modulus. Bulk modulus K is equal to dP by minus dV by V, dP by dV by V. See, negative sign means volume decreases when increasing pressure. Okay. So next we are going to discuss about some problem related to these properties. See here, I have given several problems. I'm not discussing entire problems. I'm discussing two important problems regarding viscosity index. So first one, a sample of all these two problems are very important. There is a 100% chance that it will be asking for a 3-mark question in part A. Dicto question, there is no change in values will be there. This same question will be asking, there is a chance. So you have to study the two problems, minimum these viscosity two problems, viscosity index problems, and you have to go through the other basic properties problem also. That's not much important. So first, a sample of oil with viscosity index of 70 is tested with 0 viscosity index oil and 100 viscosity index oil, whose viscosity values at 100 Fahrenheit are 375 and 125 SUS. What is the viscosity of sample of oil at 100 Fahrenheit in unit of SUS? So viscosity index is equal to L minus U divided by L minus H into 100. This is the equation, viscosity index. Here viscosity index is given. So we have to find out what's the viscosity of the sample of oil. U we have to find out. So L is the viscosity of 0 viscosity index oil at 100 Fahrenheit. H is the viscosity of 100 viscosity oil at oil at 100 Fahrenheit, and U is the required viscosity in SUS. So we have U is equal to 200 SUS. This is the first problem. It's a very important problem. You have to study 100%. There is a chance that the question will be asked. Second important question is, a sample of oil is tested with a 0 viscosity index oil and a 100 viscosity index oil whose viscosity values at 38 degrees Celsius are 400 and 150 SUS respectively. If the viscosity of the sample of oil at 38 degrees Celsius is 200 SUS, what is the viscosity index of sample of oil? So here we have to find out the viscosity index. So viscosity index of sample of oil is L minus U divided by L minus H. L is viscosity of 0 viscosity index oil. H is viscosity of 100 viscosity index oil. U is the viscosity of sample of oil. Then we have to substitute the values in the equation. We have 80 viscosity index. See, these two problems are very important. There is a chance that it will be asking for a 3-mark question. So to this section I am winding. In this section we have discussed about the properties of hydraulic fluid, almost 12 properties of hydraulic oil. Then viscosity index, that's very important topic, viscosity index equation and problem related to viscosity index, and some general properties of hydraulic fluids. Okay.